Hi to everyone. In this video, let us discuss chemical equilibrium lesson here. In that first introduction topics. So now, first of all, before going to chemical equilibrium, let us know what are types of chemical reactions here. That too related to chemical equilibrium. In that, the first one is irreversible reactions. So what are irreversible reactions? See here, the reactions which takes place only in one direction are known as irreversible reactions. That what are the examples for here? Decomposition reactions, neutralization reactions, explosive reactions. In all these reactions, the reaction takes place in one direction only. Means reactants give products, but products never give reactants. So like that, reactions takes place in one direction known as irreversible reactions. Okay, then the second one is which one? Reversible reactions. The second one is here reversible reactions. Reversible reactions means what here? First, reactants give the products, and again after some time, that products again give which one here? Reactants. That means the reaction takes place in two directions. Two directions means what here? Reactants giving products, that is one direction. So reactants giving products, again products give which one? Reactants. So like that, the reactions in which both forward and backward reactions taking place, that is known as reversible reaction, or those are called reversible reactions. Forward reaction means reactants giving products, and backward reaction means products giving reactants. And this reversible reaction indicated with oppositely, that present half-headed arrow marks pointing in opposite directions. So with this symbol, we can indicate that reversible reaction. What are the examples of reversible reactions? First one is here, N2 plus 3H2 gives 2NH3. All these are present in gaseous state only, N2 and H2 also. And the second example here, 2SO2 gas plus O2 gas gives 2SO3 gas. This is second example. And H2 gas plus I2 gas gives 2HI gas. This is the third example here for reversible reaction. And decomposition of limestone CaCO3 will give CaO solid plus CO2 gas. But one condition should be there, closed vessel. So this reaction is said to be reversible only in closed vessel. Why like that? Because if the reaction carried out in open vessel, what happens here? The CO2 present in gaseous state escape out from the vessel. Therefore, we can't expect the backward reaction. So like that, the compulsory condition, the mandatory condition for this reaction is closed vessel should be used. Okay. Another example also we can take here. NH4HS solid gives NH3 gas plus H2S gas, and PCl5 gas gives PCl3 gas plus Cl2 gas. So, and also another one example also there, hydrolysis of ester. Hydrolysis of ester means CH3COO C2H5 liquid. When subjected to hydrolysis, we get which one? Acetic acid. acetic acid plus ethyl alcohol. So these are the examples we have to remember for reversible reactions, because in competitive examinations we get the questions like this: which of the following given is an example of reversible reaction? But they may not give this equilibrium symbol, they give normal arrow mark only. But if you remember these examples, one of them you can identify. So these are the examples of which one? Reversible reactions. Okay, now after that, here let us go for equilibrium state. So first, what is equilibrium state and how it is attained, let us see here. If you consider any reversible reactions, initially forward reaction takes place vigorously. Let it be the which one? Rate of reaction, and this is time. As time increases, rate of forward reaction decreases, and let it be the rate of backward reaction. This is velocity or rate of forward reaction. Let it be the velocity of backward reaction. So initially velocity of forward reaction is maximum, velocity of backward reaction is minimum. But as the time increases, velocity of forward reaction decreases, velocity of backward reaction increases. After some time, both the rates of reactions will become equal. That Vf equals to Vb. That state is known as equilibrium state. So what is the definition here? The state at which velocity of both forward and backward reactions are equal. That state is called, which one here? Equilibrium state. So with one general example we can see this one. Let it be the A vessel and let it be the B vessel having same size. Both vessels having same size. Now let us connect these two vessels at the bottom. Now first fill total. Now first here we have to connect them with a knob, and here first fill the A bottle or A vessel with water. Now in this B vessel, no drop of water, a single drop of water also not there. But if we open this knob, what happens here? Water flows from A vessel to B vessel, but total water does not move into the B vessel. Only half of that amount will flow into that B vessel. Once the level of water is equal, we can't see any increase or decrease in the level of water in both the vessels. So now here this state is called which one? Equilibrium state. But actually here at this equilibrium state also there is a flow of water from A to B and also B to A. If we are having any doubt in that, to check that, if you add any color in A vessel water like blue color or any other color, after some time we can see the appearance of same color in the B vessel also. So that indicates what here? There is a flow of water from A to B also at this stage. But if A to B water is flowing means, why there is no change in level of water? Very simple. Because at this time A to B and B to A water flows but in equal amounts. That means here if 10 ml of water flow from A to B, at the same time 10 ml of water flow to B to A. So like that, what that indicating? Velocity of forward reaction is equal to velocity of backward reaction. So now here at this equilibrium state also, both forward and backward reactions continue to take place. Means they are occurring still and still, continue to take place. But both are with equal speed. For that reason, we can't observe any change in which one here that level of water. And similarly, if you consider H2 plus I2 gives 2HI example. So initially, iodine is having that blue color, thick blue color we can see. But after some time, due to the formation of HI, an equilibrium is established. But as the reaction proceeds, the thickness of this blue color decreases. But after some time, a constant color is maintained for so much time. That means there is no increase or decrease in the color of the iodine or color of that reaction mixture. That indicates what here? Equilibrium is established. So like that, we can identify the establishment of equilibrium by the constancy in some physical properties like color, density, etc. So if no change in color or any other physical property of reactants and products, that point indicates that the reaction has been reached equilibrium state. And another general example here. Of course, we may not believe if water level no change means no one can believe that A to B, B to A water is flowing. But it is true. How we can prove that here? Already we have given one example. Blue color added means after some time it appears in B bottle also. But another general example here, for example, let it be the highway road. Four-way are there, not only single way, four-way is there. For example, if one bus is moving here and another bus try to overtake this A bus. This is A and this is B. For example, if we are sitting in this bus, A bus. For example, if the both buses are moving with the same velocity, 70 kilometer per hour, 70 kilometer per hour. If they are moving like this, by sitting in one bus, if you observe that second bus, we feel that that bus has been stopped, not in moving condition. But actually at that time also, both the buses are moving. That means at equilibrium position also, both forward and backward reactions are continue to take place. That means it is looking like a static in mode, but that is not correct. Equilibrium is dynamic in nature. Dynamic in nature means at the equilibrium both forward and backward reactions continue to take place. That we have to remember. So one of the important characteristics of equilibrium is dynamic in nature. Equilibrium is dynamic in nature. Okay, now let us see here some characteristic properties of equilibrium. So what are the characteristics of equilibrium? So the first one is velocity of backward reaction is equals to velocity of forward. Forward and backward both will become equal. Velocity of forward reaction is equals to velocity of backward reaction. And second one is equilibrium is dynamic in nature. And third one is equilibrium can be established from either side of a reaction. That means by considering reactants, if you start the reaction, after some time one can observe the formation of equilibrium. Otherwise, if we start the reaction by taking products, also after some time we can observe the formation of equilibrium. For example, last example here, if two bottles we have taken, now if these two are connected, to get the equilibrium here, we can fill the A or B bottle with water. But after some time, we can see the formation of equilibrium. There is no mandatory condition. That means we have to fill in A vessel only. We have to fill in B vessel only. No mandatory condition. By filling the water either A or in B vessels, after some time, one can observe the formation of equilibrium. Like that, equilibrium is established from either side of the reaction. That means if you want to see the formation of equilibrium for H2 plus I2 gives 2HI, we have to that go for that reaction by considering either reactants or products first, but after some time we can get the equilibrium. Okay, then another property is here. At equilibrium, physical properties like color, density, viscosity, so etc., like this, all these properties of reactants and products remain constant. They know, that means the no change in that properties. There is no change in the properties like physical properties like color, viscosity, density, etc. Okay, then another important thing is here. At equilibrium, number of reactants and number of products remain same without any change. So remain same without any change means some students may get confusion. Here I am saying the number of reactants and number of products remain same. Remain same means here no change in the number of reactants. That means concentration of reactants no change. Like that only, there is no change in number of products means concentration of products. But this is not means that how many reactants are there, same number of products should be there. This is not that type of concept. Here what we are saying, how many reactants are there, they remain as it is without any change, and also number of products also remain same without any change. So one example here, for example, here this is A classroom, this is B classroom. In A classroom 60 students are there, in B classroom 40 students are there. For example, if A to B 5 students are moving at the same time, B to A 5 students are coming. That means here outgoing and incoming students are remained same. That means let us consider velocity of forward reaction is equals to velocity of backward reaction. That means this state is called equilibrium state. But once you can observe here, if 5 members outgoing and 5 members incoming, always this number remain as 60 only. No change in number of reactants. Let us consider these as reactants. No change in number of reactants. And here also 5 members incoming, 5 members outgoing. So no change in the number of students in B classroom also. That means at equilibrium, the number of reactants and number of products remain constant without any change. And then another important thing here, at equilibrium, number of reactants may or may not be equal to that of number of products. That means here if you observe 60 reactants are there, 40 products are there. That means here that number of reactants are not equal to number of products. And of course, in that another case we can consider 60 members. Now second case, here also 5 members outgoing, 5 members incoming. Already equilibrium is established here also, but here the number of reactants and products are same. That means here at equilibrium, the number of reactants may or may not be equal to number of products. That is not the condition. That should be equal or that should be not equal. No mandatory conditions are there. May or may not be equal. So next, another one here. at equilibrium, if any reaction is present, concentration, pressure, and temperature will affect the position of equilibrium. These three factors will affect which one here? Position of equilibrium. For example, here in A and B, water present at equilibrium. Now, by adding some more water in A vessel, what happens now? Forward reaction takes place vigorously. That means by changing the concentration, what happened here? There is somewhat more forward reaction. So like that, by changing concentration of either reactants or products, one can change the position of equilibrium. And also another thing is here pressure. For example, let these the flexible bottles. Now what happens here? If you apply the pressure on a bottle, now what happens? Water flows from A to B vessel. That means by applying pressure also, we can change the position of equilibrium. So like that here, concentration, pressure and temperature will affect which one means equilibrium. And if delta n equal to 0, pressure has no effect. What is delta n? Number of gaseous products minus number of gaseous reactants. If delta n value 0, that reaction is not affected by, that equilibrium not affected by which one? Pressure. So these are the characteristics of which one? Equilibrium. Now let us see types of equilibrium. So based on physical states of reactants and products, two types of equilibria is there. What are the two types of equilibria? First one is homogeneous equilibrium. Homogeneous equilibrium means what here? That reactants and products both are present in same physical state. So example here, H2 gas plus I2 gas gives 2HI gas, or PCl5 gas gives PCl3 gas plus Cl2 gas. So like that, if both reactants and products are present in same physical state, that equilibrium is said to be homogeneous equilibrium. And the second one is here heterogeneous equilibrium. What is heterogeneous equilibrium? The equilibrium in which reactants and products are present in different physical states. So example here, CaCO3 solid gives CaO solid plus CO2 gas. Here all that reactants and products are not present in same physical state. So this is come under which one? Heterogeneous equilibrium. Another example we can go for NH4HS solid gives NH3 gas plus H2S gas. So this is also an example of which one? That heterogeneous equilibrium. Okay, these are the characteristics and types of equilibria. Okay, in our next video let us go for which one? Law of mass action and equilibrium constant. Bye.